This is the third video looking at the quantitative chemistry topic. So we've looked at the idea of relative masses, we've looked at the idea of what the mole is. You may well be thinking, well, what's the point of this all? The point of that is all for this type of question. These are what's known as reacting mass questions, where you work out from a mass of one thing in an equation, what mass of another thing will take part or will be made in the reaction. They look a little bit complicated at the start, but I'm going to show you a wee method here which should work for pretty much all of them, and very quickly you'll get into your head how you approach this style of question. So I'm going to go through all 6 of these questions. These are found on page 7 of your notes. Again, it's up to you how you approach that. You might want to follow along with the first one to get the idea, or the first one or two. Then pause the video, have a look at the rest yourself, and then come back to it and I'll go through the rest of the answers there. So I'm just going to plough on ahead to question 1 to 6 in front of you. So what the question actually says, or usually shows, is an equation. So this one's copper oxide plus hydrogen goes to copper plus water. What also gives you in the question is a mass for one of the things in the reaction. So in this case we got 40 grams of copper oxide. And it generally will ask you to work out the mass of one of the other things in the equation. So it could be something on the left hand side that's reacting, or something on the right hand side which is being made. And the goal of the question is, from the bit of information about one reactant, you're able to work out the mass of one of the other things in the equation. So the best way to lay this out at the start when you're just starting off on this is what we call the table method. Generally involves is you write a little table for your equation. So copper oxide plus hydrogen goes to copper plus H2O. Every single part of the equation gets its own little column in the table. And then down the left hand side the rows will have the following titles. Ratio, I'll explain that in a second. Mass in grams, RFM we've looked at before, and moles we've looked at before. First thing to fill in is the ratio. So the ratio just means how much of something reacts with how much of something to make how much of something plus how much of something. In other words, it's the balancing numbers in the equation. In this case, quite simple because there are no balancing numbers. So that just means one copper oxide reacts with one hydrogen to make one copper plus one water. So in this case, just 1 to 1 to make 1 to 1 ratio. It's quite a simple one. What the question gives us is only one mass. It gives us 40 grams of copper oxide. So the mass fits in this bit of the table, copper oxide, 40 grams. The goal of this question is to work out the mass of the hydrogen that reacts with that 40 grams. So if I kind of fill in what I'm aiming for, it's just part of my table here I'm looking to get the answer for. What that means is that these two parts of the column in this particular question aren't actually that important, so I'm going to strike them out. In another question, you might have to work out the copper or the water, but generally it'll only ask you to work out one other column, not all 3 of them. So with that kind of filled in, here's how you approach it. If you look at the ratio, it's a 1-to-1 ratio of copper oxide to hydrogen. If you weren't being careful, you might think, hold on, if 1 copper oxide makes 1 hydrogen, 40 grams should make 40 grams. It doesn't work that way. You can't use the ratio for the masses because these things have different relative formula masses, so you have to take that into account. The ratio will only help you once you've calculated the moles first. So that's where you actually start. Your first step in this question is to calculate the moles of the one they give you the mass for. And you should remember your equation for moles. Moles is mass over RFM. So I need an RFM, copper 64, oxygen 16, add in the calculator, that's an RFM of 80. Therefore the moles becomes 40 divided by 80, which is 0.5. Once I know I've got 0.5 moles of copper oxide, now is when I use my ratio. So it says 1 copper oxide will make 1 hydrogen, therefore 0.5 moles of copper oxide will make 0.5 moles of hydrogen. So I use my ratio to guide how I go from this column for moles to this column for moles. Now, moles aren't the same thing as mass, so to get my final answer I need to be able to work out this number of moles back into a mass, but we have done that before. The equation used for that is that mass equals moles times RFM. So I need my RFM for my hydrogen. Now I need to be really careful here. With formula which have like wee numbers in it, like diatomic things, the rule is If it's a number as part of the formula, you count it. If you had a big balancing number there, you wouldn't count it. The balancing number is only for the ratio. So this is H2. The formula is 2 hydrogens. Therefore, the RFM is 2. So to get my final answer, it's moles times RFM. 0.5 times 2 is 1 gram of hydrogen being made there. And that's what the question was asking for. Okay. Example 2, we'll move on to. So this next one says, what mass of oxygen reacts with 192 grams of magnesium? So again, it gives me an equation. I'll write it out first and then turn it into a table. So 2 magnesiums reacts with an oxygen to make 2 magnesium oxides. Give everything its own column in the table and give ratio, mass, RFM and moles. Okay. If I look at what they give me in the question again, they give me that I've got 192 grams of magnesium, so I'll put that into this part of the box. And it's asking me to find the mass of oxygen at the end, so that's the missing part of this table I'm trying to aim towards. That therefore means that I don't actually need the magnesium oxide part of this table. Again, in a different question I might have to find that, but I'm only asked for the oxygen in this question. Okay, first step is finding the ratio, and again, this is different to the first one, which was all just ones. We have actually got balancing numbers in this equation. This tells me that 2 magnesiums reacts with 1 oxygen to make 2 magnesium oxides. Therefore, the ratio between magnesium and oxygen is 2 magnesiums reacts with 1 oxygen. So I'm going to use that later. Remember, the key bit is I can't use that ratio for the masses. I have to turn it into moles first. So I use my equation, moles equals mass over RFM. I therefore need the RFM. Be really careful here. When you're working out the RFM of something like this, the balancing number does not count. It's only for the ratio. So in this case, the only part of that formula actually is just the magnesium itself. Its mass is 24. Therefore, to get my moles, I do 192 divided by 24, which is 8 moles. At this point, I can use my ratio, so I've got something to do now because it's not a 1-to-1 ratio. This tells me that every 2 magnesiums only reacts with 1 oxygen, so it's a 2-to-1 ratio. Therefore, if I have 8 moles of magnesium, it's going to be divided by 2 to end up being 4 moles of oxygen. So this guides you how you convert from one mole to the other. You divide 2 by 2 to get 1, you divide 8 by 2 to get 4. So I've got 4 moles of oxygen being made. I now need to turn it back into a mass. So mass equals moles times RFM. Again, being really careful here, what I said before was if it's a small number as part of the formula, you count it. If it's a big number, you don't. So there's no big balancing number here, so nothing to worry about there. But that little 2 is part of oxygen's formula. Therefore, I have to count it. It's O2, so 16 plus 16 is 32. So the calculation I do to work out the mass is 4 moles times by the RFM 32, which gives me 128 grams. Moving on to question 3. So I've got sulfur dioxide and oxygen to make sulfur trioxide. So give it another little table. Okay, first thing I fill in is the ratio just from the equations. That's a 2 to 1 to 2 ratio. If I go back to look at the question, what it gives me? It's asking for the mass of sulfur trioxide. It gives me the mass of sulfur dioxide, SO2, 96 grams. So I'm going to fill that in here. And as I said, it's looking for the mass of sulfur trioxide formed. So this is the one I'm trying to work out. So in this case, the other reactant oxygen I'm not interested in, I can get rid of it from this table. Same as before, need to use my ratio, need to use my moles. So I need to convert this into moles first. The RFM of sulfur dioxide, there's a sulfur, there's 2 oxygens. That big 2 is only for balancing, not for the RFM. So I just need to add this bit together. 32 plus 16 is 64. And there for my moles is mass divided by RFM. 96 over 64 is 1.5 moles. Now I use my ratio. This might seem a wee bit tricky because it's a 2 to 2 ratio, but if you think about it, if 2 becomes 2, that's the same as 1 becoming 1. It's also the same as 1.5 staying as 1.5. So it doesn't actually change the number of moles with that ratio. Back to the mass, I need mass equals moles times RFM. RFM has got an extra oxygen, ignoring the big balancing number. 32 plus 16 plus 16 plus 16 gives me an RFM of 80. To work out the mass, it's moles times RFM. 1.5 times by 80 gives me 120 grams of the product. Question 4. What mass of carbon monoxide is needed to react with 480 kilograms of iron oxide? This one's got a wee twist in that the mass is given in kilograms, but that doesn't put us off. Equation Fe2O3 reacts with 3 COs to give 2 Fe plus 3 CO2. Ratio, mass, RFM, moles. Ratio first is a 1 to 3 to 2 to 3 ratio, just from the balancing numbers. In terms of what the question is asking for and what it gives me 480 kilograms of iron oxide. However, I need to remember I need to give it in grams because the moles calculation only works when your mass is in grams. Timesing that by 1,000 gives me a mass of 480,000 grams of iron oxide. The mass I'm trying to get is the carbon monoxide, so that's C with one oxygen, CO. So that's my missing mass here. RFM to get moles first, need to add up that formula. There's no balancing numbers to ignore. Just 2 irons and 3 oxygens is an RFM of 160. Moles, 480,000 divided by 160 gives me 3,000 moles. So even though it's really big, it's just the number of moles. My ratio, it's a little bit different. It's a 1 to 3 ratio. So I multiply by 3 to get from Fe2O3 to 3CO. So times by 3, it gets me up to 9,000 moles for the carbon monoxide. I want to get back to mass, so I need to use mass equals moles times RFM. The RFM of carbon monoxide is just a carbon plus an oxygen. Ignore the balancing number. That is 28. 12 plus 16. 9,000 times by 28 to get my product is actually 252,000 grams. If you want to give that in kilograms, it would be 252 kilograms. Question 5. What mass of carbon dioxide is produced when 5.6 kilograms of butene is burnt? Gives you an equation. Let's make a table. Okay, ratio first. It's a 1 to 6 to 4 to 4 ratio. That took the question. Now, with this question, it says 5.60 grams of butene. Obviously, you don't know what butene is yet. You learn about it in 5th year chemistry. But for now, we'll just tell you it's C4H8. So that's the mass I've got. Mass I'm trying to get is the mass of carbon dioxide produced. So that is this column here. So the other 2 columns I do not need. And this is my mystery mass I'm trying to calculate in this equation. Same as before, I need my moles first for my ratio. Moles of butene, I need to work at the RFM. 4 12s plus 8 ones gives me 56. Moles is going to be mass divided by RFM, 5.6 over 56, which is 0.1 moles. The ratio from this to this is 1 to 4. So I need to multiply by 4 to get the moles of carbon dioxide. So multiply up by 4, that gives me 0.4 moles of carbon dioxide. To get back into mass, I need to times moles times RFM. RFM is just 44 because it's a 12 plus 16 plus 16. Ignore the balancing number. 0.4 times 44 to give the mass gives me 17.6 grams of the product. Final question. What mass of oxygen is needed to react with 8.5 grams of hydrogen sulfide? Gives you the equation there. Now I'm going to do something a wee bit differently. By now, if you follow that, you might think, hold on, I don't really need the table method anymore. I can do this just off the top of my head or with a more condensed working out. and that is fine. You don't have to use the table method. So I'm going to show you how you might maybe approach this one without using the table, but of course it will still work with that method. You've probably picked up the idea that you've got a mass of one thing at the start and trying to get a mass of the other thing at the end. You've also probably worked out the fact that you always work out the moles first of the one you have the mass for. So let's just go straight to do that. In this question, it gives you the mass 8.5 grams of hydrogen sulfide. So what I do first, if I've got 8.5 grams of hydrogen sulfide, I can work out the moles. Mass over RFM. 8.5 grams is the mass. RFM is 1 plus 1 plus 32, which is 34. That gives me 0.25 moles. I remember from my table method that once I've got the moles of one of the reactants, I use my ratio to work out the moles of the other thing I have to work out. In this question, it's looking for the mass of oxygen. So if I look at my ratio here, it's a 1 to 3 ratio. Therefore, so I'll write that down, 1 to 3 ratio. So therefore, 0.25 moles of H2S will go to, times that by 3, 0.75 moles of oxygen. That's how much of this reacts with how much of this. You might remember from the last step from the table method is once you've got the moles of your other bit in your question, you're trying to get back into a mass. So if I've got 0.75 moles of oxygen, I'm going to use mass equals moles times RFM. RFM, remember I don't use Bansk's number, just O2, so that's 16 plus 16, which is 32. Giving me a final answer of 24 grams of oxygen. So if you've understood those 6 questions, brilliant. If not, remember you can obviously email and ask for help from your teacher. If you have got your head around that, what I suggest you do now is to look at the section of the question section at the back of your booklet, which starts like this. Here you've got 3 sides of mole questions. Most of them are the same as this, reacting mass questions, but obviously written like they would be in the exam. So what I'd say is have a go at as many of these as you can. The mark scheme I think has been uploaded to the Google Classroom. What I'll probably will do as well, I'll try and upload a video showing the working out for all these questions if you need a wee bit more clarification of how you approach them.